In today's session, we will be seeing about non-restoring division, in which we will take a simple example of 12 by 5. So whenever we are going to divide 12 by 5, we are going to get the remainder as well as the quotient as 2. Right? So the first process is the 12, it is going to be written in your binary. So the corresponding value of your binary is 1100. And then the divisor is 5, which we are going to write it as 0101. So as we have seen in the restoring division, the same way we are going to go in for your non-restoring division also. We are going to take the three registers, namely A, Q and M. Okay, so initializing, we are going to initialize the register A to 0. Q, it is going to be the dividend, and M, it is going to be the divisor. Okay, so this Q register, it is going to be taken as a number of bits is 41100, but when we are going to consider A and M, so it should be N plus 1 bits. So the actual value is 0101, but we are going to add in front one more 0. Here also generally we are going to take 4 zeros, but initially we are going to add one more 0. So A and M will have 5 bits, whereas Q will have 4 bits. Okay, so A, Q, M has been done with. Then we are going to fix the count. Count is going to be 4. So how many iterations this cycle of calculations has to be proceeded with? It takes the number of cycles to be 4. Now we are going to check whether the A value is going to be less than 0. If it is going to be less than 0, we are just going to check whether it is yes or no. So if the value is going to be 0, then we are going to perform A is equal to A minus M. So what is this A minus M? A minus M is nothing but the 2's complement of the value. It is nothing but A plus M bar plus 1. So we are going to take the 1's complement and add 1 to it. Suppose if the result is 1, then we are going to do the simple addition. That is A equal to A plus M. Now we will move on to your problem. Okay, so then what we are going to do? Then again, we are going to check whether the value is 1 or 0. If it is 0, we are going to change it to 1. If 1 means we are going to change it to 0. Then once this process is completed, then we are going to decrement the count. So it says that one complete cycle has been done with. Then this has to be proceeded till the iteration count is going to be 0 or not. Okay, so then we are checking whether the A value is less than 0. If yes, again we are adding A equal to A plus M. And whereas in the other case, if the condition is false, then we are going to end the process. Okay, so the only difference between the restoring and non-restoring division is that in restoring division, so we have to restore the A at each and every cycle, so which constitutes more calculations and more timings when respect to your non-restoring calculations, which just involves the simple addition and subtraction process. Now, moving on to the problem. So we have taken the divisor value and the dividend value and the initial carry. So as usual, similar to your restoring division, we are going to neglect this carry. So what is the first step we are going to do? It is nothing but we have to discard the carry and shift the values of the registers of A and Q left by 1 bit. So we have just moved the bit by once in the left, and this is the next bit. So it has been shifted left here. The remaining bits are 100. So that has been put forth here, and a vacant place has been created. So once this process has been done with, the next thing is what we have to do. So if the bit is 0, then we have to do A minus M. So we are going to do A minus M. Okay, so M is nothing but 0101, that is 5. At the side, I have just calculated the 2's complement and I have kept with. So what is this? So the 5-bit digit is 00101. So when I take the 1's complement, it will be 11010. So you are just going to invert the zeros to ones and ones to zeros. Then plus 1 you are going to add. So what is the value now? It is 11011. So now this value is going to be added here, and then we'll just perform the addition process. 1 plus 1 is 10, 1 plus 1 is 10, 1, 1, and here you have 1. So what is the next condition? If it is going to be 1, you have to change the value of Q naught to be 0. So 1 is there, that will be changed to 0. So one complete process is done with. So you have to decrement the count by 1. So 4 count will become as 3. Now we'll take the data. What is the data? Again, we have to shift left. 11001. So 11001 has been shifted left and 3 zeros are there that has been done with, and one more empty place has been created. Right? So now once shift left is done, so you have to check the value. What is the value of the first digit MSB? So that is 1. So if it is 1, then what is the condition? We have to do A equal to A plus M. So what is M value? So 00101. So that has to be added here. So what is 1 plus 1? It is 10. 1. You have a carry as 1. 1. 1. 1 plus 0 is 1. Now you check the result. The MSB value has a 1. So if you have 1, what it should be done? 1 should be replaced by 0. So 1 will be replaced by 0. Okay, so once this is done with, the second cycle has been done with, so you have to reduce the count by 1. So this completes your second cycle. Now, with the remaining value, so whatever is your value now, so 111 00. So the data have been shifted, and here you have 3 zeros. So this one would have been substituted here. So that one 000, a vacant place will be created. Now here the input is 1. So what we have to do? You have to do add the M with A. So I'm again adding 00101, and you repeat the calculation. 1 plus 0 is 1, 0. 1 plus 1 is 10, 1. 1 plus 1 is 10, 1. 1 plus 1 is 10, 1. So whenever I'm going to have a carry, I'm going to discard the carry as per 2's complement. Now this 0 is there. So this 0 will be replaced as 1. Okay. So once this change has been done, 0 has been replaced by 1, then you have to reduce your count value. So third cycle has been completed. As usual, for the next stage, as usual, what you have to do? You have to shift your A value and Q value. So 0001 is there, and this 0 will be shifted here. The remaining 3 digits are 001, and a vacant place will be created. Now you have the value as 0. So in that case, what you have to do? You have to do as A equal to A minus M. So I've taken the 2's complement value and I'm going to add it now. So 1 plus 1 is 10, 1 is there. So 0 plus 1 is 1. Okay. Now here 1 means what you have to do? Again, we have to change it to 0. So finally, I'm having the data as 11101 and then 001, and this 0 is 1 means it has been changed to 0. Now, once when you're getting 1, again what you have to do? You have to do the addition process. That is A is equal to A plus M. So whenever you're going to do the A equal to A plus M, what is the value? So when you're adding, you're getting the remainder as 0010, and the quotient which is stored is 0010. So remainder and the quotient what we have obtained is equivalent to your decimal value of 2. So that you can do by the manual calculation and verify it. So this completes the process of non-restoring division. So just by the simple process of your addition and subtraction, so this non-restoring division can be performed inside your ALU. Thank you.